this session we will see what is erosion and dilation, and we also discuss a problem on opening and closing. So first we consider a figure, that is, this is my image A. Okay, this is my image, and consider this B is my structuring element. So first we discuss what is erosion. Okay, so erosion is denoted by this symbol, that is erosion of image A by B. It is denoted by this symbol, A erosion B. So erosion is actually, if this is your B, if I take the translated versions of B, that is I just translate B over A, the result of erosion means select all the points such that this B is fully contained in A. Okay, so here consider I am placing B like this. Okay, so this is my center point of B. So in this case, if I choose this as my center point of B, this B is fully contained in A. So here I can select this point. Similarly, I can select all the points in A such that when you place B, when you place a translated version of B, it should be fully contained in A. So what you will obtain is an image like this. So if this distance is d by 4, this width will be d by 8. So if I place a d by 8 inside, similarly this is again d by 4. If I place d by 8 inside, it should be fully contained in A. So the result of A erosion B is shown in this figure. Okay, so the dotted line, that is a dotted rectangle shown outside, is my original image A, and A erosion B will be the shaded rectangle. Now consider an elongated structuring element. Now this is my structuring element. Now I have the same image A, I have to do erosion with this structuring element. So in this case, if I place this structuring element like this, if this is my center point, this will be fully contained because this length is D, this is again D, so it will be fully contained. Okay, so this width is D by 4, so this point, the center will be halfway, so it will be D by 8 inward. So a point D by 8 inward, this will be, when you place this as a center, this B will be fully contained in A. So I can select this point. Similarly, I can select all the points through this up to D by 8. Is it? Because if I place here, again it will be fully contained in A. So I can select all the points till D by 8. If I slightly move this structuring element like this, consider I am slightly moving it upward. What happens? My B is not fully contained in A, so the center points cannot be chosen. So in this case, the center point cannot be chosen. So all this will be the only allowed one. So the result of A erosion B will be a line like this. So the length of the line, it will be, if this side is total side length is D, this will be D by 8 inwards, and here it will be D by 8 inwards. This will be the result of erosion B. Now we see what is dilation. So dilation is represented by this symbol, A dilation B. It is represented by a plus in a circle, inside a circle. So this is A dilation B. In the case of dilation, we actually take the reflection of B and its translation. Reflection of B and its translation. Okay, so here I have considered a symmetrical structuring element. It is symmetrical around the origin, so the reflection of B will be the same. So I will be considering only the translations of B. So consider this is my B, and B and B reflections are the same. So in the case of dilation, the condition is when I take the translated version of B, it should share at least one point in common with A. So if I have B placed like this, consider I have placed B like this, and this is the center, it is sharing one point in common, at least one point in common with A. Okay, so that means this point I can choose. Okay, so clearly if this total length is d by 4, this center will be at d by 8. So all the points d by 8 above I can choose. Similarly this with this d by 4. So if I place it like this, if this is the center, again this B is sharing at least one point in common with A, so I can select these center points. Okay, so the total length is d by 4, so up to this it will be d by 8. Okay, so all the points d by 8 apart I can choose. So the result of a dilation V will be like this. That is a dotted rectangle. It actually shows, this dotted figure actually shows the original image A, and full shaded region shows the result of a dilation B. Now again you consider the same image. Consider the same image A. Consider I am going to do the dilation of the same image with an elongated structuring element as shown here. Okay, so here also your condition is you need to share at least one point in common with A. So if I place it like this, and if this is my center, it is sharing at least one point in common with A, is it? So I can choose this point. So you know the total and this D. So what will be this distance? It will be D by 2, half D by 2. So D by 2 upwards I can choose. Similarly, all the points D by 2 upwards I can choose. Similarly, consider I am placing it like this. Okay, placing this structuring element like this. So this is the center point. Again you can see it is sharing at least one point in common with A, so I can choose this point. So this distance is d by 4, so up to center it will be d by 8. So d by 8 towards this side I can choose. Okay, so this will be the result of a dilation. Now we know what is erosion and what is dilation. Now we move to a problem related to opening and closing. So consider this is my image A. So this image A is given, and consider B is my structuring element. You have to do opening of A by B, and similarly you have to do closing of A by the structuring element B. Okay, so in this case, first I consider the opening. So opening means I have to do erosion first. In opening I have to do erosion first, and this is followed by the dilation. Okay, in opening I have to do erosion first, and then it is followed by the dilation. Okay, so first we have to do erosion. Erosion of A by B means, as we already seen, erosion means when you place B, that is when you place a translated versions of B, it should have, erosion means it should be fully contained in A. Okay, so this B is 1, 1, 1. So you can choose the center points where it can be fully contained in A. 1, 1, 1. I cannot find any point in which it fully contained, is it? There is no 1, 1, 1 horizontal direction, there is no 3 ones in here, so it is not fully contained. So what will be the result of erosion? The result of erosion will be all zeros. Okay, all zeros. The result of erosion will be all zero. So this will be the result of erosion. Now I do dilation. Okay, so 0 I am doing dilation with 1. So if I place this B anywhere, there will not even a single overlap, because there is no ones in your result. Okay, so the result of erosion followed by dilation is again this one. Okay, so the result of opening will be all zeros. Now you consider closing operation. So closing is defined as, we have to first do dilation. We have to first do dilation, and then it is followed by erosion. Okay, closing means first you do dilation and then followed by erosion. So this is the operation. So first you have to do dilation. So dilation of A by B means, dilation means when you take the translated version of B, actually the reflector and translator, you consider the symmetrical. So when you take the translated version of B, it should have at least one point in common with A. Okay, So consider this point. Okay, consider this point. I am placing it this point. When I place it this point, is actually having one point in common with it. Okay, because it is already 1. So I have this point as 1. What happens when I take this as my center point? When I take this as my center point, again you can see you will be having 1, 1, 1. Again it is overlapping with this position. So this will be again 1. What happens when I take this as my center point? When I take this as my center point, there is no overlap on both sides as well as the center. Okay, now all this will be 0. Now you take this as my center point. What happens when you take this as my center point? Again I will be having overlap with this one. Okay, so you will be having this as 1. Consider this as my center point. It actually overlap with 1. Consider this as my center point of B. It will overlap with the left one. Okay, now consider this as my center point. There will be no overlap. Consider this as my center point. It will be having overlap with the right one. Consider this as my center point. It is actually overlapped with 1. Now consider this. It will overlap with the left one. Similarly, when I consider this row, here I will be having, when I place this as the center, there will be an overlap. When I place this as the center, there will be overlap. When I place this as the center, again there will be overlap with the left one. Similarly, when I take this as the center, there will be overlap with the right one. When I take this as the center, there will be overlap with the center one. Okay, so my result of dilation, after dilation, what my result I obtained is 1, 1, 0, 0, 0. Then I will be having 1, 1, 1, 0, 0. Then it is 0, 1, 1, 1, 0. Next row is 0, 0, 1, 1, 1. Next row is 0, 0, 0, 1, 1. So this is my result of dilation. Now we have to do erosion. Dilation is followed by erosion. Erosion means when I place this B111, it should be fully contained in A. So wherever I have a fully contained in A, when I place it any position over here, it is not fully contained. When I place this as my center, that is when this figure, when I place this as my center, it will be fully contained. Is it 1, 1, 1? So this will be one position. When I consider this row, when I take this as my center, it will be fully contained. Similarly, when I take this as my center, it will be fully contained. Other position, it is not contained. So my result of dilation followed by erosion, that is closing. Result after closing will be all these rows will be 0 because there is no full overlap. All this will be 0. Here I will be having a 1. Okay, all other will be 0. 1, 0, 0, 0. Then here I will be having a 1. All others are 0. 1, 0, 0. Then here I will be having a 1, 0, 0, 0, 1, 0. Then the last row, there is no overlap. So all will be 0. 0, 0, 0, 0, 0. So this will be the result of closing. That is dilation followed by erosion. Okay, that is all about opening, closing, erosion and dilation.